Okay, hello everyone. I'm again. Okay, in this lesson, we'll write these two message things. Pygist, of course, we haven't written the send message yet, so let's write the send message first. We have a send message here, but it's still empty, right? So how do we do this? Send message. Actually, this is executed through the main thread because it's called in the main thread. So we send this message through the main thread. First, we need to convert the message we sent here, but we don't want to send too long a message. We'll just forward it. Actually, it's a bit abrupt. We'll just forward it directly. Then let's check the length of this message. We'll convert it to a single word type. Everyone, better not send Chinese. Try not to send Chinese. We'll mainly use English. That's fine. If you're interested, you can set it to UTF-8 or something and try it out. We'll just convert it to English like this. Then this way of writing is actually quite troubled and quite dangerous, but we don't care. We'll just send a shorter one. Just don't send it too long. If it's too long, there will be problems with this. It will be truncated. Then we prepare an integer to check how many characters we have sent. And then if this value here is greater than what we want to send, greater than the size we specified, we just set it directly. Tell it that this size is too big. It just won't work, right? Because in this part of ours, we don't want to make it too complicated. Because if you make this TCP complicated, it really becomes extremely complicated. So here, we only need to limit the impact because we're only making one alternative arrangement. So it's too big. Here, we'll just directly prompt that sending failed. Right here, as for this deduction, it's actually a callback to the blueprint. What information did we send? Then here, we actually need to send this information. That is, if it meets our size requirement. We can just send it like this. We directly call our socket method and then just pass it through. And then we pass this in here. Okay, of course, this might fail because this will return a Boolean value. It might fail, so we need to. If it fails, we will prompt here that our sending of the information failed. If it succeeds, we call this place the send success. Such a delegate, that is to say our message has been sent out. Okay, so this is sent through our runnable. When our runnable sends, it will trigger the send success delegate. Then our main thread, it can actually perceive what information we have sent. So in fact, binding a delegate like this is when message sender. Then we need to look here because if we fail, a proof there is a problem here. The characters you pass might be too long. So we can output this log here. I'll add a log entry here as a fallback. Remove the accommodation. Okay, then if we succeed, we never have to do it. Prove that this information was sent. If we fail, we'll save the current information. That is, our information has failed. So for this information, we'll concatenate this information. We get which stage we are currently at. Which stage's information failed to send. We concatenate this information into this string right here. And this place is our. This is where we will make the call. That is, when we encounter a problem, we close it here because all our information failed to send. So we handle it here. Because sending and receiving information, sending information may fail. After we finish handling this sending, we will start writing our OnMessage stage. In the OnMessage stage, first, if we write it step by step, first, we definitely need to use a switch. I don't know why recently this switch, it seems like it. This thing seems to be for some unknown reason. I have no way to automatically generate it for me. All such enumerated things, let's just ignore it. We'll just write it ourselves. First, our first phase is definitely connect or sys. After we successfully initialize, it should be the connect or sys phase. Yes, then we need this enumeration. Okay, when it is this phase, then we also read here, meaning that if this code contains this, the information we received contains 220. So how do we do it? We just let it send this message to the other side. So we let it send this EHLO thing, and at the same time we set the state to this EHLO state. Then we just wait for the next state to come back. And if it is not this, it means we have a problem. It means our process might be wrong. Then we say, this hello server, greeting, the server failed. Then we directly go to state close. We have a problem on our end, so we just shut it down. Okay. Then remember to definitely hit break. Hitting break here is especially easy to miss. Particularly easy to miss. If you miss it, then you will encounter you sent a wrong phase or a situation where the information was sent incorrectly. Okay, let's confirm and compile. It should be okay and pass. Okay, if it passes, there's no problem. This place should update the API. Let's ignore it for now. Don't update the API for now. Okay, then to the second stage. After this information is sent out, then we wait for it to be received. After it is received, go to the second stage. We then send the EHLO information. Okay, we are connected. Then at this stage, we need to check whether it contains this 250 information. If so, we send this. The second one means we need to log in. We need to request login. Then the next stage, just enter the username. As you can see, the first stage is right here. We will receive this. The first piece of information is this. Then the second piece of information, we send the first piece of information as this. Next, we receive the second piece of information as this. Next, we send the auto login. So this place corresponds to this stage. Okay, no problem. Okay, let's continue. Next, we send the username. For the username, we need to perform a base64 encoding. So we need to include base64. Let's go to the very top, the base. Let's include all these header files at once. Otherwise, other issues might pop up later. Okay, first of all, we definitely have this one-step action, right? This O-step action might be used. Then we might use paths. We'll include that as well for convenience. We might use base64. Yes, then we might use these things, include them. Some header files might be redundant. I'll just rely on them. Can't be bothered to manage it. Okay, after the inclusion is complete, we go back to our place. Okay, we will encode this name with a base64 encoding. After the encoding is complete, we just send it over. So this stage is this. It asks you, it will send a 334 asking what your name is. Then you encode the name and send it over. It then asks you another 334, your password. What is your token? Okay, then let's continue to look at our 334. Next is our this stage. As you can see, the front and back are actually connected. And then at this stage, what we need to do is put this here. Okay, then we encode our token, send one over. Then it's done. So in the next phase, it means this phase is complete. This means the base64 password is complete. At this point, it will prompt you whether the login was successful. Obviously, we might fail the login this way because you wrote the wrong password. This is very possible. So if you get this 250, then it proves your login was successful, right? Then after we log in successfully, we need to configure some email attachment parameters. For example, which email address it was sent from and who the recipient's email address is. So here, both are 250, which is also simple. Okay, so here 235. It means this place has passed verification. Then next, we will start to do the setup. It is equivalent to the sender. Yes, the sender should be the sender information. Okay, right here. Okay, so this first 250 is the sender. After the sender is set up, we then set up this recipient. Set up the recipient. Pay attention. This break here is really easy to miss. Very easy to miss. Don't miss it. Set up such a recipient. After the recipient receives it, then we break it. Then next we start preparing for this data phase. Because after you send this, it will give a 250 indicating okay. Then next, we need to prepare the data. As for preparing the data, it will actually give you, let me check. It should enter this data preparation phase. Then it will send the 354. It will send prompting you that you need to send data in a data phase. Okay, so let's take a look at it here. Whether it is something like 350, if it is, it proves that everything before is okay. If not, we say this phase reported an error. Then here we write the previous info as a toString. Right, there is an info here. Here's the string. Then we give it an end. Okay, after this phase is completed, actually it means here it will give this. Because we gave this end field, he will then give a 250 okay, meaning it has been queued in. Then afterwards, we start sending the exit for this phase, right? It means that our data, this phase has been completed. So we directly send an exit message to him. Then after he receives the exit message, he will give you a 22. He will give you a 221 by message. Okay, So here we give him a 2, 1, 2, 1. Quit. Okay, this is what this part is about. We have truly arrived at this quit phase. We exit. Okay, it's equivalent to our current phase. That is our failish. This is the completion and ending phase. Okay. If we don't find it, then we give an unknown error. It could be that we wrote the code incorrectly, or its interface has changed. This phase is not quite correct. Okay, so we have basically gone over this information. Let's first see if it compiles successfully. Let's compile it again successfully. Okay, good. Okay, let me show you this again. First of all, we receive the first message, 220. Then we send a greeting. Then we receive the second message, 250. Then after that, we have a request to enter. Double again, phase after the auto login phase is completed. We start sending 334. Send our username and token, then the username token. After receiving 235 verification success, we start setting the recipient and sender. Then the 250 is here. After OK, next we transmit data. Transmitting data corresponds to the 354 command, then the 354 command. After we successfully transmit it, finally we request a quit with a 250 OK. Then it gives a 221 to say goodbye. Okay, complete. Good. Actually, in this final part, you see each stage, if we quit, we will eventually make it go through the stage close process. Then here it will be equivalent to going to equivalent to closing this runnable. So as long as this runnable is closed, it will go through the runnable's callback. Then the runnable is here. There is a callback here. That is when it is closed. It will first release its own thread resources. After the release is complete, then here it is released. After the release is complete, it will destroy the given one. It will call to close the agent. Then we return to our main thread. Through this asynchronous method, we return to the main thread here. When this unclosed, we can scroll down further. It should be here. Here we will find the information about our closure. Okay, good. So basically it is like this. Good. Here I will comment out this OnMessage. Comment out this message, because when we test later, there might be that key. I need to protect this key from other systems. I'll just comment out this line. Actually, if anyone needs it, they can uncomment it. Okay, let's compile it. It should be fine. When closing, it will call the corresponding blueprint. That means we have completed this part. Finally, we notify our management system. The save action has been completed. You destroy that smart pointer. Okay, in the next lesson, we will do a simple test like this.